In 1886, the first internal combustion engine-powered car was invented by Carl Benz. Soon, there were many cars that used the combustion engine. Airplanes, motorbikes and boats followed shortly after. People's ingenuity led to using the combustion engine in places that the inventor might not have imagined. The same happened to JavaScript. New JavaScript environments such as Node and NPM are now available. JavaScript's home is in the browser. That's the environment in which it was used for several years. Essentially, it was a front-end only language. Then, in 2009, a developer named Ryan Dahl decided to use Google's JavaScript V8 engine and make it work on the server. It's not always easy being an innovator. Many doubted whether it was even possible. However, the idea caught on, and more people started getting on board. This is how Node.js was born, and how JavaScript became a language for both front-end and back-end. Node.js is a separate, standalone environment. This means that Node.js can run in multiple settings. For example, on the command line, in a desktop application, or on the back end of a web app. Before the introduction of Node.js, developers had to build backends in other technologies and languages such as PHP, Python, C#, Ruby, and Java. After Node.js became available, it was possible to use JavaScript on the backend or on the server side. This means that today you can write full-stack JavaScript programs. In other words, you can write JavaScript on the client and on the server. Node.js comes with a package manager called NPM. The package manager allows you to use a large number of libraries and frameworks as Node.js modules. An NPM module is a standalone piece of code that has been published on the NPM website. Sometimes an NPM module is also referred to as an NPM package. Okay, so now that you've learned about Node.js, you may be wondering how you can use it locally. Node.js and NPM are either pre-installed on your machine or you need to install them. Once installed, you can interact with Node.js and NPM from the command line. For example, you can run the node command inside your computer's command line. This is also called a shell or a terminal. In the same way, you can run the npm command. You may be wondering why you need to run those commands. Well, this is because you use the node command to run a JavaScript file or to directly execute JavaScript code. You use the npm command to install any node module from the npm repository. For example, you could install the module named lowercase. Once installed, you can import this module and use its functions to transform strings to lowercase in your code. When you want to start a new project, first open a folder on your machine where you want to place your project files. Then run the npm init command. These projects can be different shapes and sizes, but they all have at least one thing in common: the package.json file that gets created after you run the npm init command. The package.json file holds all the instructions on all the node modules that are pulled from the npm repository of open source modules. There are about 11 million modules in the npm repository. It means that you can get thousands of hours worth of other developers' coding by running the npm install command and adding the package name. Examples of libraries you can install include React, Webpack, Bootstrap, and Angular Core. The package.json file updates when you install a new package. It keeps track of everything you need to have installed in your project. This makes such projects easily portable. For example, if you have built a project with a specific number of different node packages, they are all listed inside the package.json file. All you need to do is share this file with, for example, your coworkers. They can have the exact same setup on their machines, simply by running the command npm install. This install command reads the contents of the package.json and installs all the necessary packages, also referred to as dependencies. Sometimes dependencies also come with their own dependencies. It often happens that when you run the npm install command, several hundred megabytes worth of Node packages get installed into your project, under the Node modules folder. In this video, you learned about the origins of Node.js. You should also be able to describe what Node.js and npm are, and how to use the basic node and npm commands on the command line. When you're building something, you want to make sure it works. And you make sure that something works by testing it, right? It's the same with JavaScript code. You need to make sure that your JavaScript code works before you launch it. In this video, I'll show you how web developers test their JavaScript code. By the end of this video, you'll be able to identify the various reasons why a developer would want to test their code, explain how the red-green refactor cycle relates to testing, differentiate between manual and automated testing, and demonstrate an understanding of unit testing. So how do web developers test their code? Let's find out by coding a custom concat strings function. For example, I can create a concat strings function to join any two strings that I give it. In this case, I want the function to join string A and string B that are received as arguments and return the result. For example, I could write concat strings ABC and then DEF, and the returned result would be ABCDEF. When the function receives number 1 and 2, it returns a 3 as a number instead of a string of 1 and 2 together, i.e. 1, 2. I can also signal what I want my function to do by adding comments to it. Adding comments will help my team understand and remember the expected behavior that I had for the function. A more detailed description would be a good way to make it more obvious as to what my intention is for each argument. In the comments, I can even specify the expected behavior when specific values are given to the function. Adding comments is a step in the right direction, but it has downsides. It allows me to write anything I like, so there are no limits on ambiguity. Also, the comment doesn't need to follow any set structure. There are many custom testing frameworks available in JavaScript. One of the strengths of such frameworks is that I don't have to use comments to describe my expectations. The test syntax itself becomes expectation documenting. When I write tests, those tests are a better alternative to comments in my source code, because they specify what expectations my source code is trying to satisfy. Tests are also callable, meaning I can execute tests to check if expectations are met. As I demonstrated earlier, I could execute the concat strings function, with the first argument being the string ABC, and the second argument the string DEF. I would then expect the function to return ABCDEF when I call it. To write this as an expectation, in some testing frameworks, such as Jest, I can use the function that has the name expect. I then pass the call to the concat strings function with the specific arguments. Then I add the toBe function, which is another testing function, and I pass it the value of what I'm expecting this code to produce. So, I'm essentially stating that I expect the calling concat strings with ABC and DEF will return the value ABCDEF. Testing in JavaScript lets me verify that the function is behaving in the way I intended. Testing code in this way ensures three things: conciseness, as it's straightforward and to the point, since there are only two function calls to explain what is the expected result; clarity, because you know exactly what argument you're providing; and repeatability, as you can run it again and again with the same arguments each time. Now, I could run multiple function calls using this syntax. For example, I could have expected concat strings with the strings 1, 2, 3 and 4, 5, 6 as arguments, and then the function to be with the argument 1, 2, 3, 4, 5, 6. And in each instance, the expectations will be correct, and the code will behave as expected. In testing terminology, you would say that your tests are passing. But I'm only halfway there. because it's still possible for my code to fail an expectation. For example, if I run the expect method and pass it an invocation of the concat_strings function with numbers 1 and 2 as arguments, my expectation of 12 being the result will fail. This is because when I use the plus operator with two values of the number type, it performs the mathematical operation of addition instead of joining the two numbers together to form the number 12, like it would form A, B, C, D, E, F if I gave it the arguments of A, B, C and D, E, F. When tests fail, you say that they are red, and when they pass, you say that they are green. If a test fails, then it's a sign that I need to write the code in such a way that its test passes. Once my test passes, I might improve the app's code without changing its behavior and without changing the test code. Changing code structure without changing its functionality, this is known as refactoring. Refactoring is the process in which I write my feature code so that it runs more efficiently or that it's easier to read and thus easier to understand for other programmers on the team. This is done without affecting the results that the code produces. The only obvious change should be perhaps the test itself, taking less time to run because I've optimized my source code. You won't always write your code in a way that meets all expectations, so it's most likely that some of your tests will be red and some of them will be green. Red tests are a guide as to how you need to improve your code to cater for unmet expectations. So, as you continue to refine your code in response to red tests, it becomes a sort of cyclical activity. This is often described as the red-green refactor cycle. This cycle is the basis of the test-driven development, or TDD, approach to programming. Let me explain the TDD approach. First, you write a failing test. Then, you write your source code so that the previously failing test now passes. Finally, you optimize your source code without changing its results. There are many advantages of having code that tests other code. For example, you can run it as many times as you want. You can run the testing code automatically, and the tests can be repeated without significant cost in time or effort. To sum up, testing is how you verify the expectations you have regarding the behavior of your code. As a developer, you are tasked to test a piece of software. How would you do it? In the next few minutes, I am going to explain what software testing is. I am going to introduce you to the three most used types of testing. You might say that testing a piece of software at a high level means making sure that it behaves as expected. In any modern software development project, these expectations are recorded as software requirements. There are many aspects of software testing, but for now, let's think of it as the act of confirming that it works, as outlined in the software's requirements. Now that I have a working definition of testing, let's think about how you might approach it. For a UX designer, testing might mean making sure that the website looks and behaves as expected. For a project manager on a software project, testing might mean that a specific piece of software works well with other parts of your system. For a software engineer, testing might mean writing code that doesn't break the existing functionality, is bug-free, and satisfies the requirements as set out in a given task. Based on what your motivations are, there are several ways that you can test your software projects. Practically, this means that there are different kinds of testing. Now, I'll discuss the following three types of testing: end-to-end testing, or E2E, integration testing, and unit testing. Let's start with end-to-end testing. A real-life example of E2E testing would be if a laptop manufacturer let his employees open some off-the-assembly line laptops, turn them on, and use them just like a normal user would do to make sure that the entire end product behaves as it should. More specific to web development, end-to-end testing tries to imitate how a user might interact with your app. This means that in E2E testing, you need to open your web application in a browser and then test it by interacting with the page the same way a user might interact with it, For example, clicking on the login button or going through the process of adding an item to the shopping cart. In other words, you're testing the entire finished software product from the perspective of the end user. Now here's something you may find interesting. The person testing the app doesn't have to be a developer. Finally, E2E tests are the slowest and take the most time to set up and run. Here are a few examples of E2E testing frameworks available on the market: WebDriver.js, Protractor, and Cypress. Next, I'll discuss integration testing. Integration testing is testing how parts of your system interact with other parts of your system. In other words, it's testing how separate parts of your apps work together. Let's explore two examples of integration testing software: React Testing Library and Enzyme. Integration tests are faster and cheaper than E2E tests, but not as fast or as cheap as unit testing. What is unit testing? Let's have a look. Unit testing is the process of testing the smallest units of your source code in isolation. A good example of this is functions. A unit is the smallest piece of code that you can test separately from the rest of the app. Practically, the smallest unit of testable code in JS is usually a function or a method. Unit tests are self-contained. They're meant to test code in isolation, preferably separate from the rest of your app. This makes unit tests fast to run and easy to write. So, that was a brief overview of the three different kinds of tests. Together, they are sometimes represented as a three-level testing pyramid. First, at the base of the pyramid are the unit tests, which have the highest speed and the lowest cost. Then, in the center of the pyramid are the integration tests, of average speed and expense. And finally, at the top of the pyramid are the E2E tests, the slowest and most expensive tests to run. You are now familiar with the three most common ways that you can test your applications. At this stage, you might be familiar with the concept of testing your code to make sure it's working as you intended. And you might also have come across some syntax of testing frameworks. But what about a language like JavaScript that has no built-in testing functionality? For JavaScript, you can use testing frameworks like Jest. Over the next few minutes, I am going to introduce you to the features of the Jest framework: code coverage, mocking, and snapshot testing. It is quite a mouthful, so let's get started. JavaScript doesn't have built-in objects or methods that would allow for tests to be written. Therefore, many different libraries have been built to tackle the issue of testing. Some examples of these libraries include Jasmine, Mocha, Carmen, and QUnit. And then there is the one that you'll cover now, namely the Jest testing framework. Jest is a JavaScript testing framework. It's often used for testing code like React, a JavaScript library maintained by Meta and a community of individual developers and companies. Besides plain JavaScript and React code, Jest allows you to test Babel, TypeScript, Node, Angular, Vue, and various other frameworks. Jest also supports code coverage. Code coverage is a measure of what percentage of my code is covered by tests. If I say that I have an 80% code coverage, that means that only 1/5 of my entire codebase is not covered by tests. But even 100% code coverage doesn't mean that you have tested for every conceivable expectation. It just means that there are some expectations tested for each line of my code. Still, code coverage is a handy tool to gauge the amount of my codebase that's included in tests. The higher the code coverage, the lower the chance of having unidentified bugs. As a rule, the higher the percentage of code coverage, the lower the amount of time required to write new tests. This, however, depends on whether there are incomplete software requirements pending, or if you are going to receive more requirements in the future. Next, let's cover the concept of mocking. Mocking allows you to separate the code that you are testing from its related dependencies. In other words, you can use the mocking features to make sure that your unit testing is standalone. For example, you can test the front-end functionality of your web app by mocking the data as if it came back from a server, when in fact it came from the client. Mocking is especially helpful because very often web applications are built by teams of developers. Some developers work on the back end of a feature, and others work on the front end. This could result in bottlenecks. Take an example where the team decides to build a new feature that lists the address book of users of the app on the front end. The actual user-related data for this feature would come from the server. But what if a back-end developer was a bit late in developing their part of the feature? Then, a front-end developer would be stuck waiting for the back-end developer to complete their work before the front-end code can be built. With mocking, you can avoid this bottleneck. Mocks allow you to pretend that the users are already there. So, the needed data comes from the mock rather than from the back-end. This allows the front-end developers to finish their side of the new feature independently. In certain cases, developers can use mocking to ship features faster. Some libraries, such as Sign-On, focus specifically on mocking. But the great thing about Jest is that you use its mock functions without any additional installations. In Jest, you use mocking by employing Jest's mock functions. It's also easy to test asynchronous code in Jest. There are no difficult setups, and tests are relatively easy to code, even for newcomers to the framework. Finally, Jest allows you to perform snapshot testing. Snapshot testing is used by developers to verify that there are no regressions in the DOM of our apps after some changes to the codebase are made. You're now familiar with the concept of testing your JavaScript code using the Jest testing framework. Great work!
In this video, you'll explore how to install the packages needed to test your JavaScript code in the Jest framework, as well as how to set up a test. Let's say I need to write a function that takes a value and adds 5 to it. I'll start by creating a new file and naming it add5.js. The code in the add5 function starts with function add5 and then val in parentheses. In between curly braces, I have return val plus 5 on the next line. And then on a new line, I have module.exports equals add5. This is a simple function which will make it easier to analyze when I write tests for it. I've also added a line to export this function so that it can be used by other files in this project. Now I'll switch over to using the Jest testing framework to write some expectations of how this function should behave. Before doing so, I'll check if I have Node.js and npm installed on my system. In the Terminal tab, I type node-version to check for Node.js, and it shows that I have version 16.15. Now I check for npm, and it tells me I have version 8.5 installed. One more step before I continue is to check if Jest is installed by typing jest -- version. In this case, it returns command jest not found, meaning that it is not globally installed on my machine. So I'll install it for this project using only npm, since Jest needs Node.js to run, and npm is a way to install Node modules into my web projects. I'll first type and run npm init-y to add a package.json file. The -y flag automatically answers yes to all the questions the init command asked during installation. Now I have my package.json file. In other words, I have a way to keep track of Node modules that this project depends on. Since I want to use the Jest testing library, I'll need to install it locally, which means installing it for this project. So I run npm install --save -dev jest. After a few moments, the package.json file will be updated with the addition of the Jest testing library. I also have a folder called node_modules, which is where the code for all the modules in this project is stored. In the package.json file, I'll need to make a few changes to the script section. In the test entry, I replace the text that is assigned to test with Jest within double quotes and save it. Now when I run the command npm run test, it will run the Jest command in this folder. So what does this Jest command do? It runs tests for the code in my project. Right now, I only have a single file, add5.js, so it makes sense to create a test file for this one JavaScript file. I'll name it add5.test.js. In the naming convention I use, I add the .test just before the .js section of the file's name. To set this file up, I'll first import the exported add5 function by typing const add5 equals require, and then in parentheses, backtick./add5 backtick. The reason for the / is to indicate that the function is in the same folder as the test file, and I've omitted the .js because Node understands what I mean even if I don't use it. So my expectation is that this function returns whatever value I input plus 5. To check, I'll use the test method with a string as a parameter that describes the test. This string will be output in the command line when I run the test, along with the words pass or fail and the function to run when I execute the npm run test command. The function will check if my expectation is correct. The string will be output in the command line when I run the test, along with the words pass or fail, and the function to run when I execute the npm run test command. The function will check if my expectation is correct. So I have test, and as the first argument, I have the string returns the number plus 5, which is what I want to output on the command line when the test is run. Then, as the second argument, I have a function which checks my expectation. I'll save and run the test, and I get back a pass result. In this video, you learned how to ready your system for testing in Jest and how to set up and run a test.
Every piece of software is built according to formal or informal requirements. The purpose of the requirements is to explain, in human language, the intricacies of what the piece of software does. So, how do the requirements tie in with the practice of test-driven development? Let me explain. Test-driven development, or TDD for short, is a streamlined process of writing code that will satisfy some requirements. Let's unpack this process a bit. On a high level, a software development team's work consists of the following: receiving requirements which will become a feature of the app that's being developed, writing a failing test for the to-build feature before it gets built, making this failing test pass by coding that given feature. In comparison with the traditional development process, the TDD approach might seem somewhat upside down. I am now going to demonstrate the TDD approach by writing a failing test for a JavaScript file and then writing code to make this test pass. To understand how TDD works, consider the following real-life situation. Suppose you have to perform a task. Drive your car to work. You leave your house and walk up to your car, only to find out that you don't have your car keys with you. Then you remember you left your car keys in the cabinet, and you simply forgot to take them. What you did there, in this imagined scenario, is the opposite of TDD. You first walked to your car, and only then did you check if you had your car keys. If you did these things using the TDD approach, you would do the following. First, you check or test if you have your keys with you. Your test fails because you don't have them. They're in the cabinet. Then, you perform the action of getting your keys from the cabinet. Finally, you check or test if you have your keys. This time, you have them, so your test now passes. What is described here is the essence of TDD. Let's go through these steps again. This time, pretend that you're implementing TDD in your code. Imagine that you need to write code in a test-driven way. Since you're coding the TDD way, you first write the test, even before you've written any actual implementation. For example, you test if a function named status of keys exists. You then use some testing functions from a testing framework. Since you haven't written your source code implementation, the test fails. Next, you run your test. The test fails because there's no status of keys function declared. The logic of your test code is, expect that the function status of keys exists. In your source code, you declare a function named status of keys. You run the test again. It checks if there is such a function and it confirms it exists, so the test passes. It's important to note that one of the rules of TDD is that you should write as little code as possible to make the test pass. For this test to pass, it's enough to just declare a function with a name. Next, you receive another requirement, which is as follows. Accept a keys variable, which should be set to true, and console log the keys variable. So, the requirement states the status of keys function should accept a previously declared keys variable, which should be set to true. The status of keys should then console log the value of the keys variable. So, you write another test, which fails again. Since you have yet to write the implementation, you write it, and your previously failing test now passes. Finally, you examine your function code and realize that the indentation is all wrong. There are also too many unnecessary comments. So, you clean up your code and run the test again to confirm that you haven't accidentally made any errors. The test still passes, so everything is okay. That is the TDD approach in a nutshell. Let's go over it one more time in a scenario. As a member of the development team, your task is to read the requirements for the software that you are writing. The requirements are passed to you by the project manager, so you get your first task for the day and start coding the TDD way. First, you read the new requirement. Next, you write a failing test. Then you update your source code so it resolves the requirement. After that, you run a test that passes. Finally, you refactor your implementation. This process is usually explained in 3 words: red, green, refactor. Red represents the failing test. Green, on the other hand, represents the passing test after you make updates to the source code. The refactor represents the final tweaks to the code that don't change implementation details, which can always be confirmed by running another subsequent test. When implemented correctly, TDD brings huge benefits to an organization because it allows for automated testing. In any platform, projects grow bigger over time and become complex. Making sure that all the tests are passing is a strong signal that the current requirement and all the previous requirements for this piece of your app have been delivered successfully and that nothing is breaking. Test-driven development has many advantages. Here are a few. With TDD, you are minimizing regressions, that is, accidental bugs introduced to old code by coding a new requirement. And you also have proof that your new implementation is not breaking other parts of the app. You can automate these tests easily and thus keep verifying again and again that the system works as expected. You can test your implementations with various inputs, and the tests become a specific kind of documentation for the new members of your team. In this video, you learned how test-driven development, or TDD, works. You also covered the steps involved in the TDD approach, and that it is implemented in red-green refactor cycles. You've completed the Testing and Compatibility module. Well done. In this module, you got an introduction to code testing. This was an insight into how web developers test their JavaScript code. During this module, you explored the importance of testing, and you examined JavaScript testing methods. Let's finish up now with a recap of the material included in this module and summarize the content by focusing on the key learning points. The history of the development of the JavaScript language was outlined, and you learned that today it is possible to write full-stack programs with JavaScript. You should now know how to describe what Node.js and NPM are, and install and set up Node.js and NPM. In any development environment, you need to check that your code works properly before you move to the next phase of its development, or release a completed program to users. An example of using the concat_strings function to join 2 strings served to demonstrate how commenting can help to indicate your code's intended behavior and how testing in JavaScript verifies that a function is behaving in the way that it was intended. Having completed that section of the module, you should now be able to identify reasons why a developer would want to test their code, differentiate between manual and automated testing, identify and describe the 3 different kinds of testing, and explore the features available to web developers within the Jest framework. Additionally, you should be able to understand the concepts of mocking and snapshot testing, explain how to test JavaScript files with Jest, and demonstrate how to write a unit test. You've put a tremendous effort into getting this far and gained some critical skills by learning about the need for code testing. You've also explored various methods used for JavaScript testing. Great work! You've completed another key part of your software development education. Keep the learning momentum going and be sure to join me for the next module.